So is the gradient of the first line -3,
Yep.
and the y-intercept is 0.
Nope.
Oh, isn't it? Isn't the y-intercept like a what when x is 0 or something like that?
Yep. What is y when x is 0?
2.
Yep. And so it's like y equals mx plus c.
Yeah.
So m is -3 and c is 2. How about b?
So uh, so is the gradient 4?
Only when it's in the form of
Like,
y equals mx plus c.
so do I have to do 4x minus 3y equals to -5?
So basically you have to make y the subject.
Yeah.
Might be easier to just put the y to the other side.
All right. So 3y equals to 4x plus 5.
Mm-hmm.
And then do I have to divide 4x plus 5 by 3?
Yeah.
So it's then y equals to 4/3 x plus 5/3. And so does that mean the gradient is 4/3 and the y-intercept is 5/3?
Yes. And so all that's illustrating is that to get the gradient and intercept of a line, you put it into the form y equals mx plus c and get it that way. And that's it. 4/3 x. And so it's 4/3 and the y-intercept is 0, 5/3. Any questions there?
No.
This one, I think you'll be fine. Take a chance to be fine. ACX. Okay, how about this one?
Okay. So I'm not sure what to do.
What do you know about the x-axis?
Is it the first coordinate is always 0?
On the x-axis, well, coordinates are x, y.
Yeah.
So anywhere on the x-axis, what do you know about those points? What do they have in common?
Oh, sorry, y is 0.
Yes. And so how could you use that?
So if y is do I have to solve the equation from then?
Mm-hmm.
So would it then be x is 2?
Yes. So it's when y is 0, so x is 2. And so the coordinates of p?
0, 2. Oh no, sorry, 2, 0, other way around.
Yeah,
Yeah.
that's it. And so it's quite common for them to ask about the like a okay, so how would you do this one?
So I'm guessing it's the same thing where I have to make 0 equals to 6x minus 18.
Yeah, and yet it's not a guess even. X-axis, so y is 0. And you
Yeah.
solve it. X is 3, and so it's 3-0.
Yep.
That's it. Let's see. Meets. It's fine. Meets the point. Okay, how would you do question 6?
So do I need to sub in 0 into both x and y, or
Yes, and then you would solve both of them separately.
Okay.
Yeah. Let's see this one. Okay. Do you remember how you do something like this?
So is this just where I need to do minus 10 over minus 6 over minus 2 minus 3, or
So minus 10 minus 6 over minus 2 minus 3. So that would give you m, and then how would you find c?
times m by 0? Oh wait, so do I then need to sub in what x and y, and then solve for c?
And which x and y would you use?
Does it? Do I just need to use the x and y from either equation?
Yeah, so you could use either a or b, but you can't mix them. So you can't do 3 minus 10.
Yeah.
Yeah. Okay. I think you're good there. I think you're good there. So this one here, it wants you to put it in this form at the end. So instead of it being y equals mx plus c, you would just rearrange it to be, you make it equal to 0.
Yeah.
And a, b, and c are integers. So no fractions. But I think you'll be fine. Find the gradient, that's okay. Oh, let's see. A line L passes, yeah, that's fine. Line L passes, has this gradient. Okay, let's give this one a go.
So do I need to sub in 6 minus 3 and a third into y equals mx plus c?
Uh-huh.
And so I need to sub in minus 3 equals to a third times 6 plus c. And so minus 3 equals to 2 plus c. And so minus 5 equals to c. And so for line 1, the equation is y equals to a third x plus, oh no, a third x minus 5.
Shift solve. Minus 5, yep. And yep, what's next?
And then I need to rearrange x plus 2y equals to 10. And so that will be,
Not necessarily.
okay,
Well, you'd rearrange it to be y equals mx plus c,
yeah.
and then what would you do?
Do I need to make it into like a simultaneous equation or something?
Yes, there is a way to do it directly right from the beginning.
Um,
We have our equation in terms of y.
Pardon?
We have our equation in terms of y.
Yeah. So, so do I just need to sub in a third x minus 5 into that bottom equation? Or,
Yeah.
and so will that be x plus 2 a third x minus 5 equals to 10?
Yeah.
Okay. And so x plus 2/3. Two,
Yeah. You don't. So see, I'm just putting it in my calculator.
yeah. Oh, yeah, I can just solve it like that, can't I? Yeah.
So it's just a linear equation. So shift solve. I'll go for lucky number 7. So it's 12. So what would you do with that? Or is that it?
Is x 15 or
Why would it be 15?
because I solved it like the old way and did like I took x plus 2/3 x equals to 20. Then I did
Why is it equal to 20?
because sorry. So
Minus 20. Oh, okay, yeah, go on.
I started from x plus 2/3 x minus 10 equals 10. Then I did x plus 2/3 x equals to 20.
Mm-hmm.
Then I did 2x equals to 30. And then I did x equals to 15.
So your one was 2/3. 1 plus 2/3 is 5/3, is it? So 5x is equal to 60. What did you do again?
I did, so I got x plus 2/3 x minus 10 equals 10.
Yeah, and then you made it equal 20.
Yeah.
And then?
And then I did, I divided 20 by 2/3 and got 30.
The problem there is you have to then also divide the first x by 2/3 as well.
Yeah, yeah.
And so you would just add these together. And so basically you get like 1 and 2/3 x, which is the same as 5/3.
Yeah.
And that's here. But Andrey, just calculator.
Yeah.
That's why I don't do the other stuff. They want the coordinates of P.
So now I need to sub in 12 to find y.
Yeah.
So do I just need to do 12 plus 2y equals 10? Oh, yeah.
If only we had an equation where y was the subject.
That means we definitely do. A third x minus 5.
Yeah.
Okay. So is the answer -1?
Yeah.
Okay.
And so coordinates of P.
Is it 15 -1?
Wasn't 15?
Oh, -1, sorry.
That's it. And so P is 12 minus 1. So first part is good. You just put them in and solve for C. And again, you can only use the letter X. And so you can see there how I just did it, calculator, and got -5. The only difference is you do have to write down your working out. So you have to write down what you put into the calculator.
Yeah.
So that was y equals a third x minus 5. It will work if you rearrange the first equation and make that one y equals. This one is already y equals, and then equal them to each other. But you're going to sub them in anyway, so you can just do it right away by putting it there. And then it's at that point that you can then just solve it. Just put it in the calculator and solve it. Just like it was a quadratic. If it was a quadratic, you wouldn't bother doing the formula. You would just put it in. Same thing here. And then use the y equals 1 to get the y coordinate. Any questions there?
No.
Just takes practice. Let's see this one. That one's all right. Yeah, let's try this.
Okay. So do I need to sub in 5 minus 4 and a quarter into y equals mx plus 2?
Mm-hmm.
And so minus 4 equals to 5x. 5 times a quarter plus c. And so I put this into my calculator.
Yes.
So minus 4. I got minus 5.25.
Yeah. Okay.
And so the equation of the line is y equals a quarter x minus 5.25. And then it wants me to get something into ax plus by plus c equals it. So do I need to then just rearrange this equation to get that?
Yeah.
So do I then just need to do 0 equals to minus y plus a quarter x minus 5.25, or
Say it again, sorry, 0 equals?
to minus y plus a quarter x minus 5.25.
Yeah. I'll just put the x first and y second, like they had it.
I think I just need to times that by 4, don't I?
Yeah.
And so that will be 0 equals to x minus 4y minus 21.
And it says where a, b, and c are integers. What's a, what's b, what's c?
A is 1, b is minus 4, c is minus 21.
Yeah, so that's just to be safe. Part B.
Okay, and then so if it passes through the origin 0, does that mean that's its y-intercept?
Yeah.
So does that mean that it's y equals to minus 5x?
Mm-hmm.
Yeah. And then do I need to just sub in a quarter into? Oh no. Um, do I need to times x by 0, make x 0 or something, or?
No. You just have to find where they intersect. This is L2, line 2. And then this one that we were dealing with was line 1.
Oh, do I need to sub in? Oh, do I need to just make a quarter x minus 5.25 equals to minus 5x?
Yep.
Okay, and then so a quarter x minus 5.25 equals to minus 5x. And then I need to let my calculator do that, don't I?
Yeah.
Okay. And then I think I messed it up. I got 1, but I think that's probably wrong.
Why is that wrong?
Because I didn't put in like a 7 or something like that initially.
X can be 1. Nothing wrong with that. So if X is 1, what is Y?
Oh yeah, X is 1. Sorry, what was the question?
What would you do next?
So X is 1, and then do I need to sub in? So is Y just minus 5?
Yeah. And so those are the coordinates of P. And I just want to try something that you might find easier, maybe not. So this one up here, if you rearrange it to get 5x plus y equals 0,
Yeah.
You can do it using simultaneous. So last time you were saying use simultaneous equations. So we're doing it by substitution.
Yeah.
If we do it simultaneous equations, two equations, two unknowns. So the first one is we said it was see, they should leave it as equal to the number. So A is 1. So if your answer for the first one, A was 1, B was minus 4, and the other one when it's equal to the number, so that would be plus 21. And then the second one, A is 5, Y is 1, and that's equal to 0. And X is 1, Y is minus 5.
Yeah.
So whichever way you prefer, both will work.
Okay.
Any questions there?
No.
Okay. And so it's a bit easier to put it into the calculator if it's like that, but it takes a bit of rearranging. That one's all right. Let's see. Okay, I think this one is worth doing, unfortunately. Okay. Let's try this.
Okay. So I need to find the gradient, don't I? So
Yeah.
-1 -3 over 4 minus minus 2, which is equals to -4 over 6, which is equals to minus 2/3.
Mm-hmm.
And so that's the gradient. And so So it's now y equals to... Oh, and now I need to sub in an x and y, don't I?
Mm-hmm.
So I do 3 equals to minus 2/3 times minus 2 plus c. And then I put that into my calculator.
Yeah.
And then so, I got 1.6 recurring 1.6666667. So
Press answer equals.
oh, 5/3. Oh well, yeah, 5/3.
Might be a bit easier.
Yeah, and so c equals to 5/3, and now it's y equals to minus 2/3 x plus 5/3, and then I now need to take the y to the other. So now I need to make it 0 equals to minus 2/3 x minus y plus 5/3. And now I need to times that equation by 3, don't I?
Mm-hmm.
And so that'll be 0 equals to minus 2x minus 3y plus 5.
That's it.
Okay.
And they had equal to 0 on the right, so I put it on the right. Who knows? Okay, how about B?
Okay. So is that like the discriminant or something, or
No. Just a point of intersection. It's one line, it's another line, so there's only one point of intersection, so it's no need for discriminant.
okay? Um. Do I need to? Oh, is this where I need to do simultaneous equation thing?
Yeah.
Okay. So, okay. I need to make it equals to, so minus 2. So I'll put down minus 2, minus 3, and minus 5, but I'm not. But I'm not sure what to do for the next. So then, do I just do 3, and then I'm not sure what to put in for the by thing. Oh, do I just put in the answer from the previous equation?
Yeah.
So minus 3, and then equals to 1. Oh, I got x is 6/5 and y is 13/15.
I don't believe so. But let's see. So if we were subbing this in,
Yeah.
and I use the y, so it'll be 3x plus b times y, and we previously said that y was 2/3 x plus 5/3 minus 1 equals 0. And we know that in that case, x will give us k. So the solution for that would be equal to k. That's a lot of stuff for 2 marks. I'm gonna take your word for it on your one. So that's question 9. What is this one? Maybe I'll just look this one up. That is, we want pure 1. Let me see, what one is this? I don't even know what chapter it is. So it's gradient and y-intercept. Straight line graphs. And this is question 9. It's fine. It's fine. I'm not gonna overthink it. Okay. You're good. This one. Gradient 3 and y5 has this equation. Find the values of a and c. That's fine. The straight line L pass through that is great. That it intersects this line at point P. That's the same. Straight line with this equation. That's very similar. You'll be fine. So gradient and y-intercept. How do you feel about that?
I'll give it in between a half and a tick, I think.
Okay. So let's see this one. Yep. Equation lines for those, yeah. This one I see, that's fine. A and C. Okay, how about this?
Okay, so do I need to do 2 different equations subbing in those 2 different coordinates?
Yeah, that'll work.
So for the first bit, do I then just need to do a plus 6 times 4 plus c equals to 0? And then do I then need to make a new equation subbing in 3a and 3? So 3a plus 6 times 3 plus c equals to 0. And then do I do the simultaneous equation thing now?
Yeah.
Okay.
So what goes where?
So the first equation, does 1 go? And 12.
How'd you get 12?
Oh, sorry, 24, my bad.
Okay, what do you do with C?
Is that just minus 1?
No. The way you would rearrange it is that you make the 2 unknowns on one side and the number on the other side.
So will that be 20? Okay, so will that be equals to minus 24 then?
Yes.
So so does that mean that the first line will be 1x plus 1y equals to minus 24?
Yeah.
And then for the second line, will it then be 3? Oh no. Will it then be 3, 1, and then minus 18.
Yeah.
And then I got x is 3 and y is 27.
That's it.
Oh, minus 27, sorry.
So paste, yes, 3 and minus 27. And so the only reason why we have to put them into that format is just because that's the one that the calculator happens to take them in. The calculator takes them in the form like that: ax plus by equals c, and that's why we just bring the c to the other side. It's just to put it into the calculator. You could always do it the old-fashioned simultaneous equations way, where you take one from the other and all of that. Or you could do it by substitution, but I think it's easier to just make it two unknowns on one side, constant on the other, and then that's how the calculator takes it in. Any questions there? Okay. Let me see. Perpendicular. That's this equation. I think you're good for that. That's fine. What do you know about perpendicular line?
It's so if one gradient is 3, the perpendicular will be like minus a third.
Yes. Let's see this one. K is constant. Okay, gradient. This is similar. Yeah. Okay, equation of a line. How do you feel there?
Probably a tick.
Yeah. And this is equation of a line through a point. An equation of a line with that gradient passes through point A. That's okay. I'll just see what the exam questions look like here. If there are any, and there are not. See the very last lines. That and that is a point L. L and M. There's a bit more to it, but it's the same idea. Parallel and perpendicular. That's fine. See the exam questions here. Hang on. This one. How do you tell if these lines are parallel or perpendicular or neither?
Okay, so do I for A? Do I need to suck? Is there a better idea to make y the subject first of all?
There's no better way. So that's it. You'd make y the subject, and then if they have the same m, then they're parallel, or if it's negative reciprocal, they're perpendicular.
Okay.
But you'll be fine.
Yeah.
I'm just going through these. Maybe this might be interesting. Yeah. So this is exam question. This is modeling. Okay. How about this?
So so is it 10 equals to Do I need to find for the acceleration? Do I need to find like the difference in gradients or something like that?
What would? Okay, go on.
So do I need to find the gradient? I mean, not difference, but the gradient for.
Yeah, the gradient.
So would I then do something like 420 and uh 831
Are you sure it's 31?
32
Yeah.
and then do I then just do 32 minus 20 over 8 minus 4, which is 12, 40, I think that's just equals to 3. So is it just then going to be 10 equals to 3 plus, or is it going to be v equals to a, no, v equals to 3 plus b10?
What letter represents the gradient?
A,
What letter is like the y?
v,
What letter is like the x?
a,
It is. What is the x-axis on the graph?
the time. Oh, so would it be 2?
Yes. And so.
Oh,
What?
the gradient is b.
Yes.
Oh, and a is like the y-intercept.
Yes.
Right, okay. So, and so, does that mean that to find a, I need to do something like, I need to sub in v, b, and c.
Sure.
So, I need to do 20 equals to, so b is then going to be the gradient which we've just got. So 20 is equals to 3 times 4 plus a, and then 20 equals 20. So is a equals to 8?
Yeah. And if you look at the graph, y-intercept looks like it's 8. And so, linear equation.
So do I need to write out the equation now?
Yeah.
So would it then be v equals to 3t plus 8?
Yeah. And I'll write it as 8 plus 3t because that's how they've written it. A plus bt. Okay, question B.
Okay, so then interpret the values of a and b. So b is just the gradient.
Interpret means in the context of the question.
So is a the velocity if b is 0 or something like that, or
Yes. And what is that velocity?
8.
Yes. And so, like at time equals 0, or basically the starting velocity.
Yep.
So yeah. So the car starts at a velocity of 8 meters per second.
Yeah.
And how about B?
Okay, and then for B, is that just going to be so considering that B is supposed to be the gradient, isn't it?
Yeah.
Is that just the constant or something like that, or
Anything you know about the gradient of a velocity time graph?
does that mean that velocity times time equals distance or something? I'm not really sure.
You said it earlier, acceleration.
So B is acceleration.
Yeah, so the gradient is the acceleration, and so the car is accelerating at a constant rate of 3 meters per second squared.
Okay.
Question C.
And then so is that just 3 times 15 plus 8?
Yep.
And then that is 53.
Okay, and part D.
This might not be a realistic model. Because is it because is it because 53 is too much of a specific number or something like that? Oh no, because it's too basic. It's not that specific enough. Or
No, I mean, it might not be a realistic model. I would say because you're extrapolating.
sorry, what does that mean?
So it's outside the data. So like with a scatter diagram, like this model is good between 0 and 10 seconds.
Yeah.
So if you say after 15 seconds, how fast is it going? So it seems like it's 53 meters per second. Oh, I can't really tell with meters per second. Like if it was miles per hour, 53 would probably be fine.
Yeah.
But maybe 53 meters per second is a huge speed, and it kind of doesn't make sense anymore. Like no car is going to keep accelerating forever and ever.
Yeah.
Yeah. So it's extrapolation. It's outside the data, so it's unreliable. So anything between 0 and 10 would be reliable. But then 11 onwards, you might get an unreliable estimate. Yes, so for this one, V equals A plus BT. And so for modeling, they swapped the, instead of MX plus E, it's like C plus MX. And they swap M with B and C with A, just kind of a convention. And so, yeah, that's the intercept, that's the gradient. And just do that. Any questions there?
No.
Okay. Oh, here's another one. Okay, draw a scatter diagram. They usually give you some paper to work with, and so that's why I don't want to mess around with that. Use this points to formulate a linear model. So I just give you some additional points. Use your model to make a linear model. This is kind of a different thing. I'll leave this for a different chapter. A stats chapter, which is on scatter diagrams.
Yeah.
Because it can be done entirely in the calculator. The charge for a taxi journey. A company is this. Write an equation. Okay, let's do this.
Okay, so so um I'm guessing, is it something like C equals to £20.40 times 5 plus B, or
So what does the C stand for?
link charge?
Yep.
So the number of moles is M. So M would be 5,
Yep.
and um, is B acceleration? No, B is the further cost, isn't it?
You said C was the charge.
Oh, right. Yes, right. So C is the charge, and so C is the charge. M is the number of miles, and now do I need to just find A and B now?
Yes, but you have to construct the equations first.
Okay, so y equals to mx plus c, and then here it's going to be c equals to am plus b. So so £20.40
Yes.
equals to a 5a plus b,
Mm-hmm.
and then um um do I need to make a 0?
You've got two unknowns.
Yeah.
You did this one.
Um. Um.
Read the question. You've got everything you need.
So a further cost per mile travelled. I'm really not sure.
What about this here?
I need to make this in a simultaneous equation, don't I?
Yep.
Yeah.
Because you've got two unknowns.
£56.40 equals to 15a plus b. Okay. And so I got x is 18 over 5 and y is 12 over 5.
18 over 5. And B was, what was it, sorry?
12 over 5.
12 over 5. And so, is that the answer?
I need to sub in A and B, don't I?
Yeah.
So, Y. And then I need to make it so C. No, sorry. So C equals to Oh, sorry.
Yeah, sure. C equals.
C equals to 18 over 5. M plus 12 over 5.
Yeah, and I just wrote them in as decimals just in case that's easier for part B or C. I'm not sure, but
Yeah.
we've got them both ways anyway. B.
Okay, interpret the values of A and B in the context of the question. So A. So is B the further cost per mile?
Yeah, and what does that cost?
£20.40.
That's not B. That's A. Sorry. That's other way around. So cost per mile would be the one next to the mile, like the gradient.
The cost per mile is
So how much would it cost for 0 miles?
0.
No. If M was 0?
2.4.
Yeah. If M was 1?
6.
And so what is the difference in cost per mile?
3.4.
£3.60?
Yeah.
So it's the other one that's cost per mile. And let me just see something for a second. I think I understand your confusion, because previously A was the number by itself. It was the intercept, whereas now it's the gradient. I see. Okay. And then what is the interpretation for B, the number by itself?
Is that going to be... So if that's the thing, which that's the charge if no miles are travelled.
Yes. And so that's this thing they're talking about, the fixed charge.
Yeah.
And how much is that?
2.4. £2.40.
That's it. That's great. And so that's a little bit more. That's the same thing. Simultaneous equations. That's good. That's great. We finished that chapter. I'm happy. Yeah, how was that for you, Andrey?
Tricky stuff, I think. Yeah.
Well, I put together all the exam questions, so for that purpose. So we're going like a bit slower than I would like, but we're doing nothing but the tricky stuff. So anyway, so do you want to do next chapter next time?
Yes, please.
And it's circles. Okay. And you said you're doing what in school at the moment?
Yeah.
Okay, so you're way back, but maybe you're doing something different order. Any questions for me in general?
No.
All right. Well done, Andrey. You did great, and I'll try to remember to post a calculator. Just have to get around to doing it.
So, yeah, thank you. Okay. Cheers.
All right. Have a good week. Goodbye.
Bye.
Okay.